Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structures. X is resorcinol, 1,3-dihydroxybenzene, an aromatic compound with 2 OH groups on a benzene ring. Y is a non-aromatic 6-membered ring, cyclohex 2,4-diene 1,4-dione or similar diketone structure containing to C is equal to O, carbonyl ketone, groups and AC is equal to C double bond, the keto form of the same molecule. Moving on to the next step. Determine the molecular formula of each. X, resorcinol, 1,3-dihydroxybenzene C6H6O2. Y, the diketone cyclohexadienediene C6H6O2. Both have the same molecular formula, so they are isomers of some type. Moving on to the next step. Determine the relationship. X is the enol form, the 2 OH groups on the aromatic ring represent the dienol tautomer. Y is the diketo form, the 2 C is equal to O groups represent the keto tautomer. The interconversion between the enol form, aromatic phenol diol, X, and the keto form, diketone, Y, via proton transfer is the classic keto-enol tautomerism. Tautomers are constitutional isomers that interconvert rapidly, usually via proton transfer, and exist in equilibrium. And for the final step. Why the other options fail? A. Resonance structures. Resonance structures differ only in electron placement, not in the position of atoms or hydrogen atoms. X and Y differ in the position of hydrogen atoms, OH in X versus CH alpha in Y, so they are not resonance structures. C. Functional isomers. Functional isomers have the same molecular formula but different functional groups that are not interconvertible by simple proton transfer under normal conditions. Although X has O and Y has C is equal to O, their specific relationship, rapid interconversion via proton shift, classifies them as tautomers, not merely functional isomers. D. Positional isomers. Positional isomers have the same functional groups but differ in the position of substitution on the carbon skeleton. X and Y differ in functional group type, enol versus keto, not just position, so they are not positional isomers. Conclusion. X, the phenol-enol form, and Y, the keto form, are keto-enol tautomers. They have the same molecular formula C6H6O2 and interconvert by proton transfer between oxygen and carbon. Therefore, the correct answer is B. Therefore, the correct answer is option B.